Hey everyone, and welcome. Today we are tackling one of the biggest questions in AI right now. How do we get these super powerful models out of their digital boxes and, into the real world? How do we let them actually book a flight or check your calendar or look at live data? Well, let's dive in.
So here's how we're going to break it down. First, we'll look at the AI's big isolation problem. Then we're going to introduce the really elegant solution, the Model Context Protocol, or MCP for short. After that, we'll meet the three key players that make it all tick, see how it works with a real-world trip planner example, and finally, we'll talk about why this whole modular approach is such a game changer for the future.
Okay, so let's start with the core challenge. I want you to picture a large language model like a brilliant mind, just stuck inside a completely sealed room. It can reason, it can write amazing things, it can strategize, but it doesn't have any hands or eyes. There's no way for it to interact with anything outside of its own walls.
And this brings us to a super practical question, right? If you ask an AI, hey, help me plan a trip, how does it actually go and check for available flights or get you a real-time weather forecast?
The short answer? They just can't. On their own, these models are purely reasoning engines. They have absolutely no built-in connection to live data or outside services. To do anything useful in the real world, they need a bridge. And that bridge is exactly what we're here to talk about.
And this is where the Model Context Protocol, MCP, comes into the picture. You can think of it as that bridge. It's kind of like a universal translator that creates a common language so AI models and the huge, messy world of digital tools can finally talk to each other properly. So if we're getting technical, MCP is a standardized protocol framework, and that word standardized is everything. For years, if you wanted to connect an AI to a tool, it was this custom, messy, one-off hack for every single new service. MCP changes all that. It creates one reliable set of rules so that any AI app can talk to any external tool just as long as they're both speaking the same language.
So how does this actually work under the hood? Well, to really get MCP, you've got to meet the three core players in its architecture. Each one has a very specific and very important job to do. First up, we've got the host. This is the central control brain of the whole operation. It's the big picture orchestrator that you, the user, are talking to. The host figures out what needs to get done, it calls the LLM to do the heavy lifting, the reasoning, and, so importantly, it handles all the security and permissions for every tool it uses. Next up is the client. Now, if the host is the brain, think of the client as its dedicated translator. And here's the cool part. For every single tool the host wants to use, it spins up a brand new, unique client. That client's only job is to manage that one-to-one connection with that tool's server and just handle all the nitty-gritty protocol details. And finally, we have the server. This is the toolbox itself. This could be a weather API, a flight booking service, your company's internal database, whatever. The server's job is just to expose what it can do, its data, its functions, and it doesn't need to know or care about the AI model that's calling it. It just does its job. So this slide really breaks it down nicely. You've got the host at the top, that's the brain making the big decisions. It uses a bunch of different clients, the translators, to talk to all the different servers, which are the toolboxes that offer the real-world functions. It's just a super clean, really smart modular design. And if we peek under the hood, all this communication is split into two layers. You've got the protocol layer, that's the language. It defines what is being said using a universal standard so everyone understands each other. Then you have the transport layer, that's the delivery. It's like the courier that just worries about how to send the messages, whether it's on your local machine for testing or across the web. Okay, so we keep saying the server is a toolbox, but what's actually inside it? What kind of special abilities can a toolbox really offer up to an AI? Well, MCP defines three core types of things a server can provide. What's really cool is how simple and powerful these are. First, a server can offer up something called resources. Just think of this as raw data. It's like giving the AI a key to a library full of files, documents, or API responses. Second, and this is the one you'll see most often, it can provide tools. These are the actual functions that let the AI do things. Actions like search for tickets or get the weather. This is how the AI gets its hands. And finally, a server can offer up prompts. These are basically helpful pre-built templates that give the AI a little head start, like a checklist for planning a vacation or a structured format for asking a really complex question. So there you have it.
You've got data, you've got functions, and you've got templates. And with just those three simple building blocks, you can basically represent almost any digital service out there.
All right, that's enough theory. Let's make this concrete and see how all these pieces actually come together in a real-world example. We're going to build an AI-powered trip planner. It all works in this really simple plan-act cycle. So first, you ask it something, plan a trip. The host, our central brain, kicks in and plans. It figures out, okay, I need two things, train tickets and a weather forecast. Then it acts. It uses one client to call a ticket server to search for trains and a completely separate client to call a weather server for the forecast. Finally, the host gathers all that info, puts it all together, and presents you with one complete travel plan. See how that works? And that little trip planner example really shows why this modular approach is so incredibly powerful. It gives us a real glimpse into what this means for the future of AI applications. At the end of the day, having a standard like MCP is about creating a real ecosystem. It gives us interoperability, meaning any tool can talk to any AI. It creates modularity so developers can build and share these little specialized skills as their own servers. That leads to scalability, because now you can build super complex AI agents that pull from dozens of different tools at once, and it keeps things safe with security, since the host is the central gatekeeper managing permissions for everything. And that kind of leaves us with this final, really exciting thought. MCP gives us the blueprint to turn basically any digital service, any API, any database, into a plug-and-play skill for an AI. The foundation is being laid for a whole new generation of unbelievably powerful applications. So the only question left is, what are you going to build? Thanks for joining us.